When you hear the word landfill, what comes to mind? Probably a giant, smelly mountain of trash, right? Well, what if I told you that a modern landfill is actually an incredible piece of civil engineering? Today, we're going to go way beyond the dump and uncover the hidden science behind how we manage our waste.
And to really grasp the size of this challenge, check out this number. By 2050, the world is on track to generate 3.4 billion tons of waste every single year. That is just a mind-boggling amount, and you can bet it's going to need a seriously impressive solution. So here's our roadmap for today. We'll start with our global waste problem, then dive into the engineered solution. We'll dissect the anatomy of a modern landfill, figure out how they find the perfect spot for one, and then we'll take a peek at what's next for landfill tech.
All right, let's jump in. It's a pretty simple equation, right? More people, more stuff means more waste. And this isn't just a problem for one town or one city. It's become a full-blown global challenge.
But here's the thing. This growth isn't happening equally everywhere. You can see that while high-income countries will see an increase, it's pretty moderate. But look at middle-income countries. Their waste is projected to almost double. And the biggest jump? Low-income nations, where it's expected to more than triple by 2050. That's why finding solutions that work for everyone everywhere is so important.
So what do we do with all this trash? Well, for a long time, the answer is pretty simple. Just find a hole and dump it in. But then, in the 20th century, we got a revolutionary new idea, the sanitary landfill. And believe me, it was a total game changer.
And the difference is just night and day. We went from these totally uncontrolled dumps, which, pollute everything and become breeding grounds for disease, to these highly engineered facilities built for one thing, containment. The whole point of a modern landfill isn't to just bury trash out of sight. It's to scientifically isolate it and keep us and the environment safe through constant monitoring.
So yeah, a sanitary landfill isn't just a place, it's really a process. It's a carefully designed facility, built on solid scientific principles, all to protect both us and the environment.
Okay, so how do these things actually work? Let's peel back the layers, kind of like a giant trash onion, and see the complex systems inside that keep everything running safely.
First up, and this is maybe the most important part, the liner system. You can think of it as a giant, super high-tech, multi-layered diaper for our garbage. Its whole job is to create this rock-solid barrier between all that trash and the ground below, protecting our precious groundwater.
And this isn't just a simple sheet of plastic. No way! It's a whole team of materials working in concert. You've got this tough plastic sheet, the geomembrane, as the main barrier. Then you have something called a geosynthetic clay liner, or GCL, which is really cool. It's like a self-healing skin. If it gets wet, it swells up and seals any tiny leaks. And under all that, you've got a thick layer of compacted clay as a final backup. Altogether, they create this incredibly tough, redundant barrier. All right, so the liner system takes care of the solid stuff. But what about the liquid? I mean, what happens when rain seeps in and mixes with all that decomposing garbage? You get what's affectionately known as garbage juice, or in technical terms, leachate. And you got to do something with it. So, leachate. It's basically a toxic soup made of all the chemicals and pollutants that ooze out of the waste. We're talking heavy metals, ammonia, all sorts of nasty stuff. If that stuff were to escape, it would be a disaster for the soil and groundwater. That's why managing it is one of the most critical jobs a landfill has. So how do they handle it? Well, the landfill has its very own plumbing system. The liner itself is built on a slope, kind of like the floor of your shower, so all that liquid naturally flows down. It collects in a network of perforated pipes, which then carry it to a sump, where it's all pumped out and sent away for proper, safe treatment. Okay, so we've got the solids locked down, and we're plumbing away the liquids. But there's a third piece of the puzzle, gas. You see, as all that organic stuff in the trash, food scraps, paper, breaks down without any oxygen, it creates what we call landfill gas.
And there are basically two ways to deal with this gas. A passive system just uses vents to let it escape naturally, but an active system actually uses a vacuum to pull the gas out through a network of wells. And this is where it gets really clever. With an active system, you can capture that gas, which is mostly methane, a really powerful greenhouse gas, and turn it into a source of renewable energy. Pretty cool, right?
The engineering for a landfill doesn't start when the first bulldozer shows up. Nope. It starts way before that. Finding the perfect spot is this incredibly complex scientific process, and it's all about location, location, location.
You definitely can't just build one of these things anywhere you want. There's a huge list of no-go zones. For instance, they can't be near airports because of the birds they attract. They can't be on active fault lines, in floodplains, or anywhere near critical sources of drinking water. It's this massive puzzle, trying to balance all the environmental, social, and geological factors.
So, sanitary landfills are already pretty sophisticated, but technology never stands still, right? The next big leap is something called a bioreactor landfill, and this changes the whole game. It shifts the thinking from just passively storing waste to actively treating it. This is where things get really interesting. So what is a bioreactor landfill? The core idea is actually simple, but it's super powerful. Instead of just letting trash sit there and slowly rot, you intentionally add and recirculate liquids, like the leachate we talked about, back through it. This acts like a supercharger for the natural decomposition process. The result? The waste breaks down way faster, which means you can reclaim the land sooner, and it generates more of that useful methane for energy.
And here's why that's such a big deal. Waste breaks down in these distinct phases over a really long time. In a normal landfill, this can take decades. What a bioreactor does, by controlling all that moisture, is it basically hits the fast-forward button. It speeds through those early phases to get to that sweet spot, the peak methane production phase, way faster. So you're not just stabilizing the waste more quickly, you're also maximizing the amount of energy you can get out of it.
So when you think about it, we've gone from a simple hole in the ground to a complex bioreactor that actually generates energy. The modern landfill really is an engineering marvel, born out of necessity. But it does make you wonder, as we get better and better at recycling, composting, and just reducing waste in the first place, will we one day not even need landfills? What do you think the next generation of waste solutions will look like?